There we go. All right. So in number 27, are you on the problem? Do you have the PDF opened up? Yes. Okay. So there's a really nice picture for number 27. I'm not going to draw that really nice picture. So if you're following along, make sure you have their nice picture in front of you. I'm just going to say that there's some object launched like this, and it does something like that, and we know we got the school buses here, and there's a ramp and all those things, okay? And I'm going to call up and right positive, but that's going to be my awful picture. You should reference the nice one in chapter 3, number 27, okay? And the reason they have it on a ramp is so we know what angle it'll launch at, okay? And it is going to go up and then come back down to the same height that it started at. So like this will be the same height it launched at because there's 2 ramps. Is that okay? All right, and let's go ahead here and then see what else they gave us. We're trying to figure out, they said 18 degrees is the angle, and we got buses that are 2.7 meters, and they gave us the speed that it launched at, and we're trying to find the maximum number of buses over which the cyclist can jump. So what we're really trying to find is, initially anyway, is x minus x naught. I'm trying to figure out how far this thing travels in the x direction, and then I'll turn that into number of buses, okay? Is that okay? All right. So that's what I'm solving for. So maybe the way a lot of students will do this, and this is good problem solving, is to start at what you're trying to find and work your way backwards. Okay? So I'm going to start by looking at the x direction. Anybody, what's the acceleration, if we assume free fall, in the x direction? 0. Are you okay with that idea? Because the only thing affecting this stunt driver when he's in the air is gravity. We're making that assumption. So I'm going to say acceleration in the x equals 0. You don't even have to write that down. You don't have to show any work, okay, for the x direction stuff if you don't want to. But I'm going to show an equation because I'm trying to find x minus x naught. So x minus x naught equals vxt. Everybody look here for a minute because this won't be the last time I do this. Everybody tune in for a minute. Even if you're tuned out. There's a reason I'm not writing v initial x or v final x. That's just as a teacher for me to emphasize to you guys that the velocity x stays the same. Okay, you can tune back out if you're good on this problem. Does that make sense? Okay, I'm just emphasizing that, hey, our velocity x never changes, okay, because our acceleration is 0. And for all of our free fall problems, you get to use this equation, okay? And now I'm very much stuck, okay? While I have a way to get Vx, do I know the time that this guy was in the air? Was that given in the problem? No, okay? But let's go ahead and get Vx. Again, this idea of kind of like working from what we're trying to find. So it was launched at, what was the number? How fast was the guy going? 33 point, dang, he's going pretty fast. That's like 80 miles per hour or whatever. Okay, so 33.5 meters per second, and what was the angle he was launched at? 18 degrees, okay? So I'm just gonna break that into the x and y components. Is that okay? All right. So my x is going to be to the right. My y is going to be up. So cosine for x, sine for y. If anybody needs to see that with me drawing the full right triangle, let me know here in just a second, and I'll add it. Okay. So my Vx is going to be 33.5 meters per second cosine of 18. And while I'm here, I'm going to go ahead and get the Vy because I know I'm going to need it. 33.5 meters per second sine 18. Make sure you guys are in degree mode. Where's my calculator? Degree mode. And, whoops, 33.5 cosine 18, 31.86 meters per second. And then I like to check to see if that makes sense. 18 degrees, way less than 45, right? So it makes sense that I would have most of my velocity in the x direction as opposed to the y. Are you okay with that? It's just a little mental check. Okay. And then v initial y, 33.5 sine 18, 10.35 meters per second, okay, for the y component. And they're both positive because I'm calling up and right positive. Still with me? All right. So now I know Vx, but I still don't know t. So I'm legitimately stuck by just looking at the x direction. Well, if you get stuck looking at the x direction, go look at the, if we're stuck in the x, go look at the y direction. So I'm going to go ahead and list my 5 variables for the y direction, And the one thing that links the x to the y is time, because time is a scalar. Are you okay that time doesn't have x and y components? So whatever the time is in the x direction is also the time in the y direction. There's no distinction there. Time's a scalar. It doesn't even make sense to say components of time. Are you still with me? All right. So I'm going to go ahead now, done looking at the x direction. I'm going to look at the y direction. So I'm going to list the 5 variables in no particular order. Acceleration, v initial, v final, and t. 1, 2, 3, 4, 5. Okay. And I'm going to try to fill out 5. Okay. Oh, and this problem could help you quite a bit with the rocket activity that we're doing right now as well. So if anybody's not sure on what's going on with the rocket activity, you may want to tune into this as well, because it basically has all of those ideas in it right now. Okay. Just we're given this instead of solving for this. Okay. All right. So what's our displacement in the y direction? Remember, try to separate it out in your brain. We go up and then come back down. Anybody, what's the displacement in the y direction? 0, because we're back where we started in the vertical direction. Is that okay? So my displacement in just the y is 0. The acceleration in the y, assuming free fall, good old negative 9.8 meters per second squared. That one's easy if you call up and write positive, right? All the problems this weekend were like that. Initial velocity in the y, I happen to have found it. But if I hadn't, I would go find it once I realized I needed it. So 10.35 meters per second. V final y, I don't know. I mean, I do know because of the symmetry. Whatever I went up at is what I'm going to come down at. But let's pretend I'm not noticing that, and I'm going to leave that as a question mark. Oh, the 5. Oh, yeah, going behind the camera. Yeah, thank you. The 5 variables here. Displacement in the y is 0 because you want this problem, right? Displacement in the y is 0 because it goes up and comes back down, just like your rocket activity. Acceleration, free fall. Initial velocity in the y, I got that stuff over here, and if you need me to fill in the gaps over there, let me know. We started by looking at x direction and got stuck, so now we're looking at y direction. The thing that they share is the time, because the time in the x and the time in the y are the same. Are you okay that time is the thing that's shared? Yeah. Okay, so that's why we're doing this now, to get time, so I can go back and get how far the guy jumped. Okay, so now I don't care about v final y, because I'm looking for time. So this is the one with the squareds. So, y minus y, or no, it's the one with v naught t. V naught t, y must equals v naught t plus 1/2 a t squared in the y direction. Is that okay? Let me double check. Y minus y naught equals v naught t plus 1/2 a t squared. Yeah, we're good. Okay, all right. And I'm going to plug in, okay, and special case. Since this is 0, it's the rare time when we actually will be able to factor. If this problem hadn't begun and ended at the same level, like if it was a cliff problem like that, you'd have to do quadratic formula or graph it or something like that. Are you okay that if this is something other than 0, the math will be different? Is everybody else okay with that? Okay, all right. I would think that came up somewhere in one of the problems, but not 100% sure on the weekend. All right, so plugging in 10.35 meters per second times t. I'm going to go ahead. I better not. I'll write it out. It's early days. Eventually, if you guys want to go straight to negative 4.9 meters per second squared, that's fine. Okay, but I'm going to go ahead and write it out here. T squared, right? And then I'm going to factor out a t. So I'm going to factor out a t, and I'll get 10.35 meters per second minus 4.9 t. Because I had a t squared here. Here I had a t. And now we got 2 solutions. Quick math review. A times b, this might be off the camera, but just listen if you're watching this. A times b equals 0. What must be true if a times b equals 0? What are the possible solutions? Either a is 0 or b is 0, right? We got 2 possibilities. So up here, for this, we have 2 possibilities. Either t equals 0, because this is like my a right here. This thing is like my b in what we just reviewed over there math-wise. So either t equals 0 or 10.35 meters per second minus 4.9 meters per second squared t equals 0. Well, this one makes sense because we're doing this for when the displacement is 0. At 0 seconds, our displacement is 0. Does it make sense that that is a possible solution? Is it the one I want? No. I want the whole time that he's in the air, not the very, very beginning that the stunt driver's in the air. So I want this other one. So then we can just solve that for t. I am going to grab my calculator. So we're going to have, it'll work out positive. If it works out negative, you did something wrong. So it'll be 10 point, well, I move it over and take care of the negatives. It'll be 10.35 divided by 4.9. We'll get about 2.11 seconds. Unless I punched a number wrong or grabbed a wrong value. Are you with me so far? Okay, so now I'll go back and I'll actually figure out how far the motorcycle jump guy goes. So this will be 31, and this is where you don't have to show the work. You could just do this on your calculator and that's fine. If the acceleration equals 0, some of you have been doing since elementary school. That's the whole 50 miles per hour, 50 miles per hour, 50 miles per hour for 2 hours. How far did you go? 100 miles, right? Just, if acceleration equals 0, it doesn't require a whole lot of thought. So 2.11 seconds, well, at least in comparison to this, okay, times 2.11 seconds, and we'll get that he goes something. Let's hear 2.11 times 31.86, about 67, a little over 67 meters. So 67 meters. All right, for our displacement in the x. Not our final answer, okay? We still have to go back and turn that into buses. Okay. Before we do that, where do we have questions? I'll call this box will be the Metro North train. This box right here will be the it's a pill. Will be the pill. The umbrella will be this box, and these people who I don't know will be this box in the picture up here. So where do you need me to re-explain? This box, the box with the pill, the box with the umbrella, or the random people's ad? What do we got? Re-explain or specific questions. We're not quite done. We got one more step. But before we do that, questions. Are you still with me? Yes? Okay. Who wants a re-explanation or a specific question? Just tell me which box. Go once. Go on twice. If you're still shaky on one, just ask. All right. You missed a bunch of this. Are you in good shape right now?
What did
Which box?
the green and yellow.
Okay, the pill. Yeah. Yeah, good.
You see how it has like A and B written? What are the
Oh,
A and B?
I was just making the comparison to A times B equals 0 over here. So like, here's one thing. This is like the A over here. Here's another. This is like the B. So like A times B equals 0. Either this has to be 0 or this whole thing has to be 0. That was me just making comparison to the math thing. In fact, I think I will erase the A and B for when we take the picture of the board, because I'm assuming somebody's going to want it. Yeah?
For the pill, did you choose that equation for a specific reason?
Yep, I chose that because I was looking for time and didn't care about V final Y. There is another one. So if you notice the symmetry and know that it goes up at 10.35, it comes down at 10.35, any equation with time in it could have worked for this problem. Is that okay? But I was pretending to be the student where I didn't realize that V initial Y was the same size as V final Y. Is that okay? Yes. But if you notice that, great. You had more choices. Yep, and they're correct. Great question. Other questions? All right, so now let's turn it into buses. So what was the width of one of the buses? How wide were the buses? 2.74 meters per bus. Yes, everybody okay with that? Let's do it the other way. One bus is 2.74 meters. There's my conversion rate. Is that okay? Now a little bit of dimensional analysis just to make sure we don't get it backwards, okay? We got 67 meters, right? So we take 67 meters and multiply by one bus over 2.74 meters so that we can cancel out the meters. So we're doing division, okay? You can also check to make sure it makes sense at the end. If we're going 67 meters, it should be lots of buses. Yes? Okay. All right, so 67 divided by 2.74, and I get 24.5 buses. But there's a problem. You either have a bus or you don't. This is like counting people. If I count students coming into the room for class today, we can't have sitting here 13.5 students. Are we good? Okay. So buses like people, and eventually someday like electrons. Okay. You've either got one or you don't. It's a specific number of them. So that means my answer is that the person can clear 24 buses, 24 buses for the final answer. Okay? Questions? Buses. How is buses spelled? Is that right? I don't know. 1S? That's why I was pausing. Is that right? All right, sure. I don't know. 24 buses. Can't remember the last time I did write buses. Probably the last time I did this problem. Questions? Questions? Are you okay?
Yep.
All right. Who wants a picture of the board? Let me stop the video before I do that. Who knows if it even recorded the whole time? Yeah, it looks like it. And we still have audio? Yay.